conditions for the scenario. And obviously, there was some prior causal sequence from something more primitive from which these initial conditions evolved. So when I say initial conditions, I only mean initial conditions with regard to this scenario.
Mm-hmm. So should we? Yeah, go ahead.
So Alice, Bob, and DummyBot are all active agents outside the blockchain. So the way in which these capabilities are represented doesn't have to be the same kind of representation we're using here. But let's assume that over here we also use signing key pairs in a similar way. And the certificate chaining there does make that assumption. Now, Alice creates an attenuator which is the 50 megabyte limit. So let's go through the active creation, which is important. So in a capability system, when one object creates another object, the creating object can endow the created object with its choice among capabilities that the creating object holds. So because the creating object, Alice, has the capability to invoke Carol, the creating object, Alice, can create this object endowed at creation time with that capability to Carol. The act of creating also gives Alice the full authority, the capability to the created object, and exclusively gives it to Alice, meaning that Alice knows at that moment that no one else has a capability to the created object. So that's the act of creation. Okay. Okay. Alice sends a message to Bob, granting Bob a capability to this attenuator. And this is, you can think of creating the attenuator as creating the doing the certificate that is the grant, and then sending the message is creating the certificate that is the authenticated context. That's a fine separation. So in any case, this message explains to Bob what Alice has in mind, why Alice is giving Bob this thing, so that Bob has some context for understanding his purpose. Okay. Now, Bob receives the message. Messages are always transient. I mean, obviously, in blockchain, things stay around forever, but in terms of the model,
messages on the blockchain, right?
Well.
Sorry, okay.
These characters are not on the blockchain in this case.
Okay. Let's ignore my comment about the blockchain. In the object capability model, which is the level abstraction diagramming now, the message once received is received. There is no more message.
Okay, great.
And what Bob has is he now has the capability, but having gotten it in the message, Bob remembers enough information so that he can use it in a purposeful manner. Okay. So now that we've diagrammed that first one, we can just iterate that same thing without so much explanation. So over here, 1 month limit is the new attenuation. This is an attenuation of this. Bob, being its creator, at the moment of creation has the only capability to it. Bob can then do the invocation, which gives dummy Bob the context for understanding why he's being granted this attenuator. The dummy bot receives the message thereby disappears, but the dummy bot now has a reference to that attenuator. Now, the dummy bot exercises the right that he's been granted. So the dummy bot, let's say, sends a store message to this attenuator. What the attenuator does, and once again, I want to explain, when we describe things in terms of certificates and calculating intersections, we're going to describe the equivalent end result, but in very different language. So right now I'm staying with object capability language. So the attenuator is an object that has a store method in the object sense, a store method. And when it receives the store method, it says, okay, is this within the attenuation that I am imposing? In other words, has the 1 month limit expired yet? And if the answer is yes, then maybe it just throws an exception back to data. But in any case, whatever diagnostic information it produces, it does not forward the message if the time limit has already expired. If the time limit has not expired, then it just, so the store message, once it's received, is then checked against the attenuation. And then if it passes that check, then conceptually a new store message that means the same thing is now sent to this attenuator. This attenuator, receiving the store message, checks, is it within my attenuation, i.e., am I staying within my total 50 megabyte budget? And if so, obviously I need to, let's say it's a 10 megabyte message. I remember that 10 megabytes of my 50 megabyte budget is used up. And
just for clarity, the example that I gave to avoid as much state was just at 50 megabytes at a time, but this is a good example too.
Okay. So it then sends on a store message to Carol, and Carol doesn't know anything about the attenuation. All Carol knows is that someone with direct access to Carol, which is the thing that has direct access in this case, is this attenuator. Someone with direct access to Carol, and therefore full rights to Carol, has asked Carol to do this store, so Carol honors that request and does the store. And obviously does it once Carol receives the message. So that's the whiteboard animation of the full picture. Now, from what we were saying earlier, I think the invocation that everybody wants to see added to the certificate level explanation is this invocation.
All right, that's the one we don't have drawn yet.
Right. So we're going to proceed to try to do that. And now we can talk about time boxing. But this was the whiteboard animation I wanted to get all the way through.
One missing piece here. We have clear types for A, B, D, and C. We know where they live. Where do the two attenuators live? What type are they? What type of attenuator maybe? What type are they and where do they live? Because you've got them in the boundary between the blockchains. We've got them sitting on the blockchain boundary in our model.
So in this example, let me see if I get it right, okay? So in this example, we've got those are A, B, C, D, C, and they have their own types. The type here for this is the initial, basically the path for the initial capability is through this certificate, right? And the attenuation is this certificate, which its caveat is down here, and it only has the type of certificate in this case. But
it's the means by which this attenuator is implemented.
Right.
So in terms of our notation from yesterday, I would place at the implementation level behind this, and now I'm going to clearly use different colors for the two levels of abstraction. Where's another color? Thank you. Yeah, I should have been distinguishing colors yesterday when we do two levels of abstraction, but the certificates are not, so I'll do that. So basically, this object actually lives in the certificate, in that the certificate is the mechanism by which this object is represented in a way that others can act on.
So conveniently, I did draw those ones in a different color than everything else. But yeah.
Okay. So that's it.
But the certificate has to be persistent. So, for example, it went from 50 to 40.
So that was one reason why I left it at a 50 megabyte per file thing as opposed to dealing with state.
Yeah,
Okay, so to give you a concrete example of how we implement this in verifiable claims, there is an attenuation field that we've been planning on putting in. We've been planning on putting in a verifiable claim. So, for example, a share attenuation is an example of this. Who it can be shared with is, the entire medical community, just my medical office, just my doctor would be kind of attenuations on that. So where does it live?
Right.
It when somebody asks you for that verifiable claim, when you send it over and you give the profile, you can add an attenuation on there and give to someone, and they can further attenuate it if they want to do it. So it lives in the object that is being passed. It's like when the verifiable claim happens, when the request happens, when I generate the profile to send back, that's where I attach the attenuation. All further attenuations can be attached to that object. So it's completely outside of the blockchain. It's just in the message passing between various actors and keys.
Well, I would say.
So I think. So you agree that we're telling the same story?
Yeah. The question is, where do we apply this technology?
Right. No,
and what is the learning curve for developers needing to use the technology?
And that's where I'm going to stop recording.